This instruction is on the aluminum tensile test. You're asked to find the modulus elasticity and the yield strength of the aluminum. The definition for modulus elasticity is the slope of the linear region of the stress-strain curve, and the definition of the yield strength is the stress for a 0.2% offset line that's parallel to the slope, and where it hits the stress-strain curve, you read off the yield strength. That's 0.2% or 0.002 inches per inch offset. Now, in order to do that, notice we have to have a stress-strain curve. So in the lab, the purpose is to develop the stress-strain curve. Again, we'll put the sample, this will be a tensile test, so we'll put the sample in the tension region in the Tenney-Solson tester. Again, it's tapered, so it's pure tensile strength, tensile loading condition. The only thing different is that in this case, we have to be able to measure the strain or measure the elongation so we can calculate the strain. So this is called an extensometer. It has knife edges that attach to the sample with a clip that are 2 inches apart when there's no strain. And as the load is applied to the sample, causes the dial to register the amount of elongation. So that means that we need a force and a corresponding elongation in order to develop this, do calculations and develop the stress-strain curve. Now, if you remember, back one of the first things you did in this class was you had a spreadsheet that had in it a load and an elongation, and from that you calculated a stress and a strain and actually plotted the stress-strain curve. So you'll go back, once you get this data recorded, you'll go back and use that spreadsheet again and develop the stress-strain curve. A couple of differences. Instead of calling this now the slope, we now know that as the modulus elasticity, so you'll change that name. And be sure to review your data and use the maximum number of data points that you can use in calculating that slope, and just make sure that they're still linear. The other difference is that you will need to construct a line, either draw it using the line function in Word, and then to have it be parallel to the linear region, pass through 0.002, and then estimate. This is truly an estimate. Estimate the yield strength.